Recall, a sequence is a list of terms. A series is the sum of that, the sum of the numbers in that list. An arithmetic series is the sum of the terms in an arithmetic sequence. Of course, arithmetic, we're talking about when you're adding something to get the next term. So we talk about sum. Remember the letter S for sum, or it's going to be a sigma problem. But they give you two different formulas for sum. One of them I think looks more complicated than the other, but they're both basically the same idea. To find the sum, you're going to want to have specific parts, like we want to have n or a1 or an. And I tell you what, pay attention to if you have that last term. If you have the last term, use this first formula. Okay. If you don't have the last term, I think you're going to use the more complicated version. Okay. So, example 7 says evaluate each sum. Find S21 for the arithmetic sequence. So before we start, understand what that means is we're going to find the sum of all of the numbers in that list. If I had to find S2, you would just add up these two numbers and get, what is that, 92? S2 is 92, or S3 would be the sum of the first three numbers. I believe that's 132. Don't write that down. I don't care about that for this problem. I just want you to understand what sum is. When it says find S21, they want you to find the sum of the first 21 numbers. So we can see that D is -4 in this problem, right? So what you could do, if you wanted to, and I don't want to do this, but what you could do is say, well, the next number is 32, and then 28, 24, 20, and you could go on and you could list out 21 numbers, and then you could add up those 21 numbers, and that's going to give you the answer. I don't want to do that. I think that's more work than it's worth. I would rather use one of these two formulas from the previous slide. So notice what we've got. I can see the first term here, A1. A1 is 48, and I see the D number is -4. I don't have this last term, though. I don't have the nth term, so I'm guessing I'm going to use the other formula here. I see that n is 21. And so let's look at that formula real quick. Sn equals n over 2 times the quantity, 2 times A1 plus n minus 1 times D. So we have everything that we need. We have n, we have A1, and we have D. So we ought to be able to do this. Let's plug in those numbers. So n was 21. We have 21 over 2 times 2 times A1 was that 48 number, plus n minus 1. Feel free to do that in your head if you want, because you know it's going to be 20. So go ahead and do that in your head if you'd like. Times D was -4. So here 21 minus 1 was 20. We're going to have 21 over 2 times. 2 times 48 is 96. And we're going to have 20 times -4 is -80. So 96 plus -80 right here. (96 plus -80), of course, is 16. So we have 21 halves times 16. 2 goes into 16 8 times. 21 times 8 is 168. So there's your answer. I would prefer you write it like this. S21 equals 168. But what that says is the sum of the first 21 terms in that sequence is 168. Part B says find the sum of the first 200 positive integers. So think about what that means. Positive integers like 1 and 2 and 3, and I'm not going to list them all out, but I know it goes up to 199, 200. All right, that's the first 200 positive integers. They want me to add all those together. I'm not going to type all those into my calculator. I'm going to use a formula. Now again, notice on your formulas, if you know that last term, it makes sense to use this formula because it's probably going to be easier. So I do know the last term. You can see the last term, A200, is 200. And A1 is 1. And then they're telling me the first 200 terms, so I can see that n equals 200. I'm going to use that first formula. S200 equals, well, let me back up a second. The formula says Sn equals n over 2 times A1 plus An. So if I'm finding S200, that's going to be 200 over 2 times 1 plus 200. Or 100 times 201. Which is 20,100. So my answer, S200, the sum of the first 200 terms would be 20,100.